Hello, everyone. This is Rich Berliner from Connected Real Estate, and we'll be starting this webinar in about 1 minute. We're just letting everyone load in, and we'll be right back with you in about 60 seconds. Welcome, everyone. This is Rich Berliner from Connected Real Estate, and I'm here today with Min Huang from Amdocs for a live webinar, Understanding Total Cost of Ownership for a Private LTE 5G Network with CBRS. And I'm glad to have all of you with us today. I see people are still loading on. Actually, the numbers are going up very rapidly, so we're going to get started, but I did want to make introductions and let everybody know what we're going to be talking about today. So without further ado, let's go on. Peter, next slide, please. Just some notes before we start the presentation. We will do what we can and answer all your questions during the material presented today. But if you have questions, please use the GoToMeeting application, the GoToMeeting webinar platform to ask your questions. You could do that through the panel you see on your screen. We're also recording, and we'll publish a link to this recording within a couple of days. So we will have a full recording of everything discussed today. Today's slides will be emailed to everyone who is registered for the event today. And if you'd like more information on this topic, you can either go to www.amdocs.com or connectedremag.com. And so next slide, please. So I want to introduce our speaker today, Min Huang from Amdocs. Min, the floor is yours.
Thank you, Rich. Can you hear me okay? Yes.
Yeah, great. Thank you.
All right. Thank you, Rich, and thanks for the opportunity to present Amdocs. Today, I'm going to talk about just a quick overview on Amdocs Open Networks. Then basically some of the material to show the increase in demand for private network and also the kind of components that will constitute what it needs to build a private LTE or 5G. Then finally, we'll talk about some of the key considerations and trade-offs that's when considering the total cost of ownership when deploying and operating private LTE with CBRS. Next slide, please. Next slide, yeah. So Amdocs One is the holistic open modular portfolio that comprises all of the Amdocs business and services and solutions. Today, we'll be mainly focusing on some of the services and solutions that's in the open cloud network, the fourth pillar on the right. But in Amdocs, we do have consumer experience and monetization type business, media and digital services like providing premium contents, and also enterprise connected society that delivers a lot of billing type platforms and fulfillment type business. But like I mentioned, I'm based in the division called Amdocs Open Networks, and Open Cloud Networks is mainly dealing with operations with hybrid network operation, virtual networks, autonomous operations, network rollout, and open 5G initiatives. So that's the holistic Amdocs portfolio that we are doing. Next slide, please. Within Amdocs Open Network, these are some of the solutions and services capabilities that we've had in the last 15 years. We've been doing a lot of planning and design activities and services. We are in spectrum allocation, especially in the spectrum access system in SAS or CBRS. We do a lot of system integration services as well. We have rollout and launch capabilities. We have our network operation team, knocks around 24/7 global for critical systems. And we have device management IoT capabilities as well. And we deploying and having most of these solutions and services for a lot of the campuses, stadiums, hotels and resorts, commercial high-rise conventions, airports, and universities that has a lot of these services and solutions that we've offered right now. Go ahead, Peter, next slide. So we see an increasing demand in private network, and private wireless network is not a new idea. It's been around for a while, but right now we see a lot of acceleration on this particular need because of multiple ecosystem and technologies that are all maturing around the same time, whether it's devices or whether it's the spectrum, the technologies, the drive to have up to go to evolution to LTE to 5G, some of the virtualization capabilities, and we see a lot of industries are now, jumping on board to really having another set of capabilities and technology for CBRS to go into private networks fast. So a lot of mission critical services, whether it's government, military, we see are looking into here. Energy industries with utilities, power plants, of course the venues, real estate, buildings, stadiums, airports, buildings, and campuses. They're all trying to have their own secure private LTE or 5G network for their own use cases. And there are some unique industrial and smart factory use cases that we see, like robotics, warehousing, logistics are also utilizing CBRS and some of this private wireless network capabilities. And all those application and use cases are really the main driver to look at some of the network requirements that's needed for private wireless networks, whether it's coverage, because it's an area that needs to be covered that's not covered right now by public networks or Wi-Fi, whether it's a remote coverage problem that's challenging for rural areas or inside the buildings. There are also applications that drives capacity use cases. So the new application that's coming up that requires capacity, they wanted to have exclusive content to drive those capacity on those networks. They have to have the reliability for some of the mission critical industries and critical applications. They need low latency and high availability type of situations. And right now, some of the unlicensed like 2.45 gigahertz Wi-Fi may not be enough to have that kind of reliability and interference management. Control as well is one of the requirements that also drive some of these private networks, whether they wanted to tailor the traffic flow properly and manage the traffic and quality of service within the enterprise themselves. So those are also one of the requirements. And of course, security, highly sensitive informations, keeping on-prem on location without going to public network, making sure those data stay secure for IoT, for applications, and any of this kind of management. So those are the kind of application use case that's driving, and those will be the requirements that will come based on the kind of applications and use cases for each of the industries. Go ahead, next slide. With the emergence of CBRS, it's a very unique opportunity we see for the enterprises. It sits nicely between full license and full unlicensed, where the license band, you usually go to the mobile network carriers and they spend billions of dollars on license and they can deploy private networks, and it's been happening in the past, but it's very expensive because of the license spectrum capabilities. But also now, people wanted to avoid going to the enterprise, to the network carriers and build their own private network based on unlicensed band. It's still a best effort type of 2.4 gigahertz, 5 gigahertz Wi-Fi type of environment, which has some limitations. And of course, FCC has approved that 3.5 gigahertz being a kind of mid-band between the licensed and unlicensed, allowing users to actually use this spectrum because there is a lot of free available spectrum that's not being used by the general incumbents that are, for example, the Navy or the fixed satellite stations. And so CBRS, they decided that, if you talk to a software called a spectrum access system, and they can protect the incumbents, you can use whatever spectrum that's left over. And there's a good chunk of spectrum that's left over in the US that's not being used right now because the incumbents no longer using that often. So whether you have a priority access license to use the 150 megahertz up to maximum 70 megahertz, or whether you are just using as a general authorized access user, it's a very small fee to utilize this spectrum for business. And this band is able to deploy 3GPP technologies like LTE and eventually 5G, so that you can be sure that it's using proper commercial grade LTE standards and security that offer the reliable services that you need for your business. So this is a great opportunity. And even if you don't have any power license today, you still have up to 80 megahertz of general authorized users that you can always use whenever you need. And if you imagine using 10 or 20 megahertz to have great coverage and capacity, can be divided if you have multiple buildings in that area using different channels. It's a great opportunity to utilize this spectrum right now to think about the kind of use cases that can drive these users. Go ahead, the next slide. So what are the key ingredients that makes up a private enterprise LTE or 5G? For sure, you wanted to have your own private spectrum, and CBRS is one of these capabilities that's helping a lot of these customers with spectrum usage to deploy their own network now with CBRS. Going anti-clockwise, the next portion you think about is the RAN, the radio access network. So for the radios that will transmit to target the coverage, the capacity, the reliability based on the vendors to be chosen. So RAN is another important factor. And next after that is the core. And this is not just your IT core that exists today. These are LTE core, 5G core you have to think about. And these are dedicated to private LTE. If you need a private LTE, you will need an LTE core to function as well. And when you come into more secure traffic data offload and control type of scenario, especially later on in the 5G world of slicing, you want to have edge computing, mobile edge computing capabilities. And so you're trying to factor in also the capabilities to have those functionalities in the private network as well for secure data, and have the performance of on-prem type of core deployment. And then embedded SIM capabilities will help with managing millions of machine-to-machine type of devices, provisioning, managing, and also allows devices who are already supporting dual SIM capabilities to have embedded SIM as an option to help with all of that management of the IoTs and all the devices. It's important to have the eSIM portion considered when you're looking at private LTE or 5G. And finally, eventually, when the 5G core is also available towards private 5G, there's a concept of network slicing that's involved. And network slicing mentality is basically each customer may have a specialized service that they're looking at. Just as an example, an IoT device service like smart metering or parking lot sensor doesn't require a lot of low latency requirements. It can be high latency, doesn't have a capacity, compared to a user who could be doing either mobile data or could be doing virtual reality, augmented reality, or gaming. So they would need a much higher capacity, much lower latency type of service. And so in 5G, the concept of slicing allows the network to be basically customized for those customers' users. So and enterprises can charge premium to allow customers to have those slices for that kind of application, even in real time, to spin up a slice. But you need a good concept of slice manager to kind of design it and deploy it and operate it to be able to offer that kind of capabilities. So those are the components to think about. It's a lot more than just a plug and play like Wi-Fi to radios and then it will work, but because there are multiple components involved and all stems from the particular application or use case that would drive it. So next slide, please. So the key consideration when you're thinking about a total cost of ownership, and the little star here, like I mentioned a few times already during the presentation, is what you want to use this private network for. We see a lot of industries using it from solving the IT network requirements to use a particular use case application, whether, for example, it's security, video surveillance, monitoring, machine-to-machine IoT, or data offload. It all depends on that kind of starting thought, and that would drive a lot of the subsequent requirements on the network load that then needs the certain hardware and software and services to accommodate for those particular application and use cases. So figuring that out is the most important, and that will, like I said, drive the network requirements, like how many sites, where the sites will be, what kind of RAN vendors, core, and those components, the hardware that's needed to make the use case a reality. To think about that. And of course, besides the hardware cost, there's also a services cost. A lot of folks don't realize that services to design, to build, to integrate and operate the private LTE network, sometimes it's definitely more than sometimes the hardware itself. And a good design, for example, would reduce the number of hardware required that you think that coverage. So, and reducing the number of hardware don't just reduce the cost of hardware, but also reduces the deployment timeline, the deployment efforts like wiring and planning, infrastructure, zoning in that some cases. So thinking about the services to design it, to build it, to integrate it, and then finally in the operational state, you want to have somebody who can help you at least guide you to how to operate a private LTE or private 5G. Ongoing, at least for a little while, to upskill the owners and employees to actually learn to manage it, because managing private LTE is different to managing Wi-Fi. There's multiple components, as you saw, and not only understanding the components, but the interworking connectivity between all of them is important as well to consider. And then the cloud versus on-prem capabilities is something also to consider. Of course, right now with virtualizations, because the technology is coming up, a lot of RAN and core can be virtualized to a certain point. And of course, virtualization comes at a certain cost as well. Much cheaper, obviously, if it can be virtualized, because it uses standard hardware that you can put in some of the software, and you don't need to have dedicated hardware to fill some of these capabilities. And by doing so, you save a lot more money than the usual vendor's approach. But there are trade-offs, and I'll talk about that in the next slide with cloud versus on-prem deployments. And so in the cost consideration, once you figure out all of those, you have to think about the one-time cost in the CAPEX model, for example, versus ongoing costs. So hardware, software, some of the software like Evolve Packet Core can be modeled as the ongoing cost, but some core vendors allow there's a one-time cost, and you just simply pay support and maintenance for upgrade patches later on. So different models also help with budgeting capabilities of the owners, and most people do prefer like some CAPEX costing, so they can figure out exactly how much is it going to cost me for the first year to the 5th year, and then how much operational expenses will be costing. But the ongoing costs, some of the consideration, of course, consist of not only the support and maintenance, but obviously the operational aspect, whether you need someone to guide you, manage the services, to manage services for you, to guide you and upskill how to manage the network, whether there's automations and analytics involved to basically have a good visibility of all of the components in the network, so that you can obviously visualize and diagnose much easier. And then finally, other components like power usage of the equipment costs is also part of the ongoing, and any field visits or support patches that may need extra hours and times, those also should be factored in the total cost of ownership type of thinking as well. Okay, next slide. So I'll go into a little bit of details on the some of the consideration, especially in the radio access network and on the core network side, because these two components generally have the biggest impact in not just the one-time costs, but also the operational cost as well for deploying a private LTE 5G network. So depending on the kind of use cases, the RAN, the coverage is a huge aspect of it. different vendors out there with different power port capability. Obviously, in CBRS, there is a limit to EIRP that you can broadcast from an indoor Category A device to an outdoor Category B device. You have to consider the kind of how much you want to cover as a campus. Is it just a building? Is it multiple buildings in between the buildings as well? So site locations matters a lot. Obviously, if you have more outdoor sites, you have more potential zoning and delays and deployment costs compared to if you're just looking at just indoors, which you own the buildings, then it's much easier. So indoor-outdoor relationship, site locations matter a lot. The power of the CBRS, like I mentioned, how much coverage do you really need? I mean, you can have a 20-watt radio that can cover 10 miles, but you may not need that much, and it's a lot more expensive compared to, say, a 5-watt radio that covers, within 1 or 2 miles, exactly has the capacity as well that you need. So some of those considerations does matter. Height of the antennas, some of this deployment we see, the higher it is, the more coverage and better it is. But when you deploy devices indoor, outdoor, there may be additional considerations of costs from the installer, because in CBRS, there is a concept of something called certified professional installers, so that when you do install Category B devices outdoor, you will require a small cost as owner to basically maintain any changes to the outdoor devices. But obviously, if you're just doing only indoor, then you don't have to worry about that certified professional installer unless it's 6 meters above ground outdoor installing as well. So there are also different.
Before you go on, can I just ask you to answer one question for me? Category A versus Category B devices. Can you just go into that a little bit and tell us which is which and what they mean?
Oh, okay, absolutely. So Category A devices in CBRS, the CBRS devices, CBRS, are basically for indoor use, Category A. And they are basically have to be transmitted at 30 dBm, 10 megahertz or less. And so they are generally not required to have something called a certified professional installer to basically verify the information that's sent to the SAS. It needs to talk to a SAS, but it doesn't need to have a certified information to make sure that the information is correct. And so generally, indoor devices, you can consider them as Category A, a certain power limit. Category B are all outdoors, and they have a 47 dBm per 10 megahertz limit. And so with the higher power, they need to register proper information with the SAS. And so why they need a CPI is that to make sure that whoever is responsible installing that outdoor devices are reporting the correct information, that all the devices outdoor that talks to the SAS, and this happens to all the SAS, so all the SAS talks to each other, would know all the devices in the area, knows all of the devices that could potentially cause interferences to the incumbent. So those devices that are outdoor needs to have this sensitive CPI information sent to the SAS so that they can make sure that when they broadcast, they do not interfere with the incumbent. So mainly, if you just keep it simple, Cat A is indoor, Cat B is outdoor, but to have a CPI, generally you don't need for Cat A, but you definitely need for Cat B. So that's the simple answer for that.
Thank you.
So when it comes to radio, besides coverage, you also want to consider capacity as well. Obviously, one radio may cover the area, but when you have multiple users, a lot more users and more machine-to-machine type users, data traffic density does matter a lot, and whether it's required to have multiple sectors covering it. Does it need carrier aggregation? Does it need multiple input, multiple output configurations that can help capacity? What is your downlink and uplink requirements? For example, you may do video conferencing, with 20 people, and you may need 2 megabit per second at least for each person. So all of these consideration requirements needs to be taken into account when looking at the design, and that would determine, I guess, also the same number of radios needed for that area, and then of course that would drive your deployment costs and all of that. So the RAN is something to consider on that. And some radios also, I forgot to mention here, are 5G ready. What that means is right now, if you're considering eventually you want to evolve to 5G, some radios are 5G ready, meaning that if you install the radio today, they just need a firmware upgrade for 4G LTE become 5G RAN, and they will be able to operate in the new transmission mode in 5G. And so you don't really need to kind of rip out the entire thing and just replace it. It's just simply a software upgrade. But of course, some of these devices that does have those capabilities may cost a little bit more, but it definitely future-proofs towards 5G as well when you get into the more high capacity type scenario. So that's something to consider there. On the core side, the deployment is one of the main things to think about when it comes to core. They also, why do people ask, why do I need a separate core when some of the radio vendors sometimes provide the core as well? And it's a good question that I get sometimes, because a lot of the radio vendors may have their own single stack solution that has the RAN and the core, sometimes even combined into a single unit to make deployment much easier. And that's fine for some use cases and application. But when you try to future-proof to later, you may think about having multiple RAN vendors, different type of radios, different type of configurations, and even as a headnet mesh network, you wanted to have Wi-Fi also there. You want to have a vendor agnostic core that's separate, that can support all of these technologies and vendors at the same time, so that if you do ever change your mind, or if you upgrade, if there's new vendors that you want to try out, you want to make sure that your core does support all of these technologies that the traffic can go on to. And so when it comes to deploying the core, you wanted to make sure that understand whether you want to do it completely on-prem, which is good, because it makes sure that all the control data and user data is localized. There's no way it's going out there. There's definitely high security, but it also makes the management a little bit harder when you try to scale to another building, because you need another hardware, and then it's hard to manage from that aspect. And of course, a fully on-prem solution also could be too heavy, in the sense that the hardware requirements that need to run it may be heavy. But like I said, if it's virtualized and cloud ready, maybe that hardware, it's not too much of a problem, because it's very generally available from like HP, Dell, IBM type of servers you can use to host those. So if you do a fully on-prem, you get all the advantage of the localized performance, low latency, high throughput, and high security, but you run the risk trade-off of hard to manage and scale. And so you want to look at, make sure you maybe have cores that are more in a distributed model, where they could basically split up the control data and the user data separately, so that you could have what they call like a hybrid deployment model. And the advantage of hybrid deployment model is you get the best of both worlds. You get the cloud. If you do a full cloud deployment as an example, all your data goes onto the cloud. Of course, there's latency issues, but it makes the remote management much easier. You can sit here, if you have multiple buildings running and the core is sitting in a centralized location on the cloud, you can simply manage that from a remote location, other devices and services and management. But having a hybrid model with a distributed core allows you to have just the user data be located on-prem, so that you get the security, the latency requirements that you need on-prem, but with a much smaller type of hardware requirement, because you're breaking out the user data only requirements on the prem, and then the control data will then sit on the cloud. So the core will be split into that half, well, I wouldn't say half, but the two components, so that the control at the end, if you do scale up to multiple buildings and multiple sites, whether you want to edge or not on some of these locations, your core control units will sit on the cloud that can manage all of them. And where the factories, for example, that requires low latency, you have an edge breakout server that allows you to install just the user plane edge core on those locations for kind of mission critical low latency type of use cases. And so you wanted to have a core that makes sure that it's virtualized and cloud ready, so that when you do manage to install either on the cloud or on the servers, they can be installed over what they call commercial off-the-shelf hardware, like COTS hardware, like I mentioned, the Dell, the HP, the IBM. And if the enterprise themselves already have servers, and they generally do because they have obviously existing networks that they want to upgrade, maybe they can reuse some of these hardware components themselves, and that could save a lot more money in terms of cost as well. If they already have hardware available and they can spin up the software required to run it on it, then you don't need to worry about buying additional hardware on those particular environment too. And one of the most important for deployment to consider with a multi-vendor core is the interoperability with some of the RAN vendors. Generally, when you deploy it, if they haven't done interoperability before, they will have to take some extra time to make sure that it's fully working. If you go with a solution that already knows the RAN and the core works together well, then you don't have to worry about some of these extra deployment timelines and costs that will go into some of this as well. And then finally, in the operational simplicity aspects of managing the both RAN and the core, you want to have alerts and dashboards and the right APIs, because you might want to have your own platform that connects to all of these components and have the visibility in the network to show where things may go wrong, to manage, to troubleshoot. We want to have the easy to use UI, so you don't have to train your employees months at a time to use this software, to have the good network control and device control if you can see everything at the same time, and also run any automation and analytics on top of it, and drive some policies and traffic so that it's easy to set up and manage on your own, with the help of some service providers to upskill managing, understanding the core and the RAN. So those are the main trade-offs to think about. Of course, you can not buy any automation systems or analytics system, but it will make it much harder, of course. And of course, the integration to APIs, if they're not open, then you may need to purchase additional software as compared to integrating with your existing management platform and things like that. So those are the trade-offs that you have to think about when it comes to operation of the network as well. Okay, next slide, please. So as I mentioned in the beginning, we see an ecosystem of technologies basically all maturing all at once right now to really drive the high demand of private network. Whether they're IoT devices that has already now have supporting band 48 CBRS directly, so you don't need to have additional CPEs to translate signals to those devices. The spectrum as well as commercialized this year, and we see a lot of customers already on the SaaS, and it's growing every day. From a network perspective, a lot of hardware vendors are now supporting band 48 on top of the existing devices. So the simple firmware upgrade to support the capability for CBRS. On the edge side, you see the capabilities for virtualized distributed core functionalities that can help with hybrid deployment of core, as well as edge applications that's functional out there. A lot of AI automation analytics is now being built, and open source capabilities to show you can take all these analytics and use it to help manage as well. And of course, there's a lot of variety of applications that's now stemming because of this whole CBRS private network is capable of having secure network. So in a sense, you need an experienced partner that can tie in all these components together. So it really gives you really a complete portfolio of the total cost of ownership from all of the use cases and all the components required to build such a network. Okay, next slide. I believe this is the last slide I have on this webinar, and just to bring it in to say, MDocs try to solve this problem of having someone to help look at the entire end-to-end solution from deployment, design, all the way to operational with our offering in private LTE and 5G, because we do offer all these services to help design, plan. We do bring in a lot of hardware partners that we have deployed in the field, in the lab, and tested to make sure that the interoperability works, the application use case that they need solve exactly that problem even fraction of the cost of some of the single stack solutions out there. And we make sure that those solutions are working before we recommend it to incorporate into the final solution. And once we have those hardware components, we also have the end-to-end system integration and rollout services that we've been doing around the world. We have the shared spectrum solution, the SAS, because we are one of the FCC's approved SAS administrators in 3.5 gigahertz. So we can offer the SAS along with all these components as well. We have our eSIM management solutions that deal with machine-to-machine integrations and provision and management. And finally, our well-proven network service and operations, where we have mission-critical systems running 24/7 around the world for T1, T2 carriers, as well as a lot of billing companies to help with make sure that the operation of the network, and we have a lot of automation and analytics to support a lot of these capabilities that we can bring in as assurance services, T1, T2, for any operations of LTE networks. Okay, and I believe that's the last I have, right? Pete.
Yep. So Pete, I think you've got, is there one more slide?
Is there one more slide, the thank you slide? Or no?
Yeah, I think that's it.
That's the last slide.
Oh, okay, okay.
So Min, I've got tons of questions and I wanted to roll through them. We've got lots from the field, but I'm going to jump in first. So two things. One, from an assortment of different things that Amdocs does, which is very impressive. It doesn't seem like other SaaS administrators have as much to bring to the table as Amdocs. Am I missing something, or does Amdocs, have you really spent the time and put this together so that you bring as much to the table as it appears here?
That's a great question for whoever asked that. We pride ourselves in the network space because when we go into CBRS, we took a different approach. We didn't want, even though we are a software company that's fully capable of just providing the SaaS, which we do today, we look at it from a holistic view to make sure that we solve an industry problem. What is the use case? What is the application out there? And we take that approach and we deploy even our own network ourselves before we went into the full SaaS operation just to make sure from an end-to-end perspective, from services to the hardware, to the software, to the automations, and how fast to deliver and deploy. From all of those background that we have in the network as a company, we utilize all that experience to build our own private network solution end-to-end, just to make sure that it does work and it does solve the industry's problem before we say, okay, we're offering a solution in CBRS, because SaaS is only a small portion of what we offer. As you see, this is only one component. We offer a variety of services and solutions. We don't build hardware, but we definitely need to have the partners supply the relevant equipments to us. But those equipments are tailored custom for us to test and make sure that it does do what it does to solve that particular application and use case. So in a long answer, yes, we do have this breadth of network services compared to the other SaaS providers, because we're not only in here for the SaaS as a company, we're here from a network experience company.
And I want to get to the questions that came from the field, but one more piece of this is, how does voice play into this? Because a lot of what you've talked about is the data piece of this, but I've been very impressed with what the potential for CBRS to bring voice to this. But are you folks capable with your internally or with partners of bringing the carriers to the table in whatever roaming or an eSIM or whatever the format is? Are you capable of doing that too in-house, or is that something you need an outside partner to bring to? We've used those before in other situations, but how does it work with Amdocs?
That's another great question. What we see from a voice perspective in private networks is a later stage in building up the network. Definitely the potential is there because it uses LTE and it allows the roaming capability to be very, very easy between LTE with the channel just settings from carrier to carrier. But what we see is the first step in deploying an LTE or private network for now, most industries making sure that the IT background and the pipe and the network is set up and we can always expand towards voice. And so if you're building a private LTE from a total cost of ownership perspective, and you immediately include voice as part of the equation, it does increase complexity and obviously the cost for that, because you require additional components within the core, within the RAN components and the devices. And of course, if voice is definitely the use case, you're looking at, bringing direct, we can do things like setting up roaming agreements with carrier, configuring the core to make sure that the roaming is available, and obviously having embedded SIM capabilities provision and manage to make sure that the phones can camp on both the carriers in outdoor and obviously the private network indoor as well.
Gotcha. Good. So I'm going to knock this one off quickly. This was the last question asked, but I think I understand the answer, but I want to make sure I'm right. And the question is, how about providing Wi-Fi for a building based on private LTE? My understanding is those are two different things, that you can't use Wi-Fi in an LTE situation, but I'm not sure I'm right on that. But what capabilities exist in the Amdocs portfolio in that setting?
Another great question. A lot of people are obviously looking at Wi-Fi, eventually Wi-Fi 6 later on, new technology to kind of compensate for the use of the private network. And there's a couple of things to think about when you think about deploying Wi-Fi versus private LTE. First of all, the security aspect of a commercial LTE with standardized 3GPP is a lot more secure than say over public 2.45 or 6 gigahertz Wi-Fi that is unlicensed, and people are not paying money to use that spectrum. Also, the security network environment with the propagation is well predicted, and the RF environment is well understood with LTE as well. So that allows the much better design and planning. And we have seen instances where total cost of ownership actually is less in deploying an private LTE compared to Wi-Fi, which is surprising to some folks, because the fact that some LTE, one base station indoor small cell could cover almost 10 times the coverage of a Wi-Fi 6 access point. And so with coverage, it beats them. And then in capacity purpose, they could support maybe 5 or 6 users per access point, while LTE can support, say, 10 to 30 times the amount of users per access point.
But the way the question was asked was, how about providing Wi-Fi based on private LTE? But those are two different things.
Oh, yeah. Of course, if you already have Wi-Fi or already thinking about Wi-Fi and CBRS, there are devices out there with a hybrid type approach where they can broadcast in both CBRS and Wi-Fi together. And so that's just about choosing the right RAN vendors to deploy when it comes to those kind of scenarios. And you definitely can do that. Yeah.
Okay, so a bunch of questions about the SAS issue. How quickly does a SAS issue available frequencies for immediate use? Is there a lag to where you may experience some downtime in a private LTE system?
I think I heard some of these questions in the past. People have concern and seeing also where, for example, an incumbent Navy that comes into place may suspend some devices for a long time that doesn't allow the devices to come back on air. So if you're registering for the first time on the SAS and there is no incumbents nearby, your grants are pretty much immediate. Within a matter of minutes, you will get a grant and you'll be able to transmit. I think the problem comes when you get suspension requests because of incumbents in the area. And so, the device themselves can be smart enough if they get a message from SAS saying there's this couple of channels are now occupied, you will be in suspend mode, and the device themselves needs to be smart enough to be able to ask for a different channel so they could camp on, especially in the upper 50 megahertz where there's no Navy. Then chances are they can get the grants quite quickly back from that. Yep. But if they do not do that, then they could wait potentially 24 hours sometimes.
Right. No, but that's what you get your first grant. But in terms of when you're already in the system, there's it's immediate when if you're looking for a channel. That channel is pulled immediately. Am I correct?
Yes, that's correct. When you ask for a channel, there's no and you get the grant, that means you'll be able to go broadcast on that channel immediately.
Gotcha. And so there's no lag time once you're in the system. Gotcha.
No.
So what should someone budget for SaaS fees, and how should they think about it?
That's a good question. I think there are the SaaS fees quite public for some of the rural wireless already today, but for private LTE, it's a little bit different. In MDOCS, I can talk about MDOCS in a way that because we have offering multiple components and services, the SaaS for us can heavily discount that if they take multiple parts or services or hardware components together, to the point where the SaaS is definitely even the lowest cost of every component that you can mention. We can definitely work with each individual people to look at the total cost of ownership and then decide, what kind of discount and what kind of bundling we can offer.
Are you willing to throw out a number at all in how they should think about SaaS as a cost, or is that something that might be done better individually?
It's better to be done individually. I mean, SaaS definitely is a small cost depending on how much total yearly you want to bundle in as a CapEx for us. And of course, a lot of SaaS providers are doing an ongoing cost, and that's an operational cost. But for MDOCS, we can also look at both operational and one-time costs to see how we can go together.
And I don't want to throw you a curve, but if someone after this call wants to get in touch with AmDocs or you personally, how should they go about doing that?
My email is my email currently on the. You will get after the presentation. Feel free to contact me directly, and we can definitely get on a call and have an introduction call to understand the application, the use cases, and then go from there.
Good. Yeah, I believe it is. If it's not on the presentation, Min, you want to give it out now?
Yeah, I thought maybe I think you read the last slide there. It's min.huang, so my first name and last name @mdocs.com.
Good. Good. That's helpful. Okay, next question. With private LTE, I'm sorry, this is a good one. With private 5G network slicing, isn't that controlled by the carrier and is no longer a true private network like CBRS would offer? I think that there may be a little bit of a misunderstanding in the private network versus the connection to the carrier. Can you address that one with network slicing?
With network slicing, the concept more and more in the industry, for full 5G network slicing require a 5G core. And so we're not there yet, and full 5G core will be rolled out in phases. But there's a concept of a slice manager that sits between the final network and the slice itself. And MDOCS have ability to address those slices in different steps of the evolution from LTE to 5G, building that slice manager that can help, that you don't need to have the carrier fully to utilize some of these functionalities. But if you want to learn more about the network slicing capabilities, you can also contact me and we can go in more details later on.
Gotcha. So the next question was about indoor CBS. Can we talk about how the right antenna choice for lots of rooms and walls? I'm thinking of a multi-floor apartment building and wanting to get the security system set up for private LTE. So there's a lot of stuff in there. I'm not sure whether this person is looking for a suggestion on the right antenna or needs to contact you to talk about that. Is that part of the MDOCS portfolio?
We can definitely talk about it because we do have partners that can provide the right solutions with whatever services required. And we want to understand a little bit more on the kind of capabilities that they're looking at. Maybe security cameras only, do they need high video surveillance, or do they have IoT sensors? It would be good to have a call, so please do contact me and we can set up a call and then go through a little bit more details on the requirements and figure it out from there. Yeah.
Gotcha. Okay, so this is a twofer question, a two-parter on Wi-Fi. Is Wi-Fi good enough for indoor use? And fixed wireless, this wasn't posed as a question, so it was just thrown out there. Fixed wireless access built on LTE to provide Wi-Fi? Question mark. Talk to us about Wi-Fi and where it fits into this equation.
So like I mentioned, there are some limitations on Wi-Fi, penetration for sure, one of them. And so when you, I heard the question of fixed wireless. When you talk about fixed wireless, generally outdoor type situations, you may, lose some power, 3 dB, 5 dB of, penetration when you go indoor. So that, if you just fully depending on Wi-Fi, you may not get the performance and requirements that you need. It also depends on how much network requirement. But at the end, you need to go through a proper design, design details on exactly the kind of latency requirements, throughput requirements that you need, and just look at the terrain and the building that's needed. So it's not a simple question saying that can one be covered by the other. You may be able to. It also depends on the kind of walls that the building has as well. So you depend a lot on the design, and once we figure out and talk and put all these requirements together, then we can figure out how that would compare. But generally speaking, Wi-Fi have limitations compared to fixed wireless, because the over-the-air interface fixed wireless or CBRS have more dedicated throughput, while Wi-Fi and even indoor devices, if you putting the CPU indoor without an outdoor, you're looking at the best effort that you can get. And Wi-Fi as a general, it's great for static environments. Like you deploy it once, never look at it again because your environment is set. But if you have an environment, like a tenant that move out and your office furniture has changed, you have to move your Wi-Fi router around the place just to get the best coverage. In a dynamic environment, which is most cases, Wi-Fi has that limitation because it doesn't penetrate through walls that well. So that you want to rely on something a bit better like LTE, which is a standardized propagation that can be tuned and managed properly.
Right. So Min, to wrap up, seems like Wi-Fi, private LTE, all these technologies are part of the tools in your toolbox, and Amdocs has got the biggest toolbox. Am I right?
I would have to say yes, right? I can't say no on this webinar if it goes out there. But we also definitely need to look at the holistic approach. A headnet approach makes the most sense in building with both Wi-Fi, offload, and CBRS. But when you're looking at like greenfield, brand new deployments, and you're considering either Wi-Fi or CBRS or one of the radios that has both, then it's definitely worth looking at CBRS because there's a lot of advantage on private LTE going towards 5G eventually. Yeah,
I agree. So Min, you've been great today. Thank you so much for this. We've covered all the questions. Oh, and one more. Can you share your perspective on what ROI works for private LTE on CBRS? I'm not sure how to answer that. How do you look at ROI for this situation?
You first look at the TCO, actually, then you look at the ROI. And I just spent, hopefully a lot of time telling people you did a lot to consider in the TCO. It's not a simple number that you can just throw out an example. It's different for every scenario and different building.
And I would assume it depends on the application.
Exactly.
ROI would depend on what the application is to a great extent.
That's exactly.
So I think we've done our best to answer questions from the field. Min, you were terrific. Thank you so much. If people want to get in touch with Amdocs and you, the information is up on the last slide. As I said, we will be sending these out to everyone. We're going to also be putting all of the webinars we're doing, including today's, up on a podcast site that will be up soon. It'll be the Connected Real Estate Podcast, and we will have all the webinars and content that we've put out there on these on a podcast too, so that people can refer back in the future. But we will be sending out a recording of this within 24 or 48 hours of this webinar. And we thank you, and we thank Amdocs for their participation here. And thank you all for being with us on this call today. And we'll talk again soon. Thank you.
Thank you, everyone. Thank you, Rich.
Thank you.
Bye.